Okay, let's go. We are live. So, hello guys, I am your code specialist Dev Jobalia. Today, going to solve your doubts on the DSA question flattening a linked list. So, today the learning possibility is very high because every day brings unique opportunities. So, previously we had done find the starting point of loop quite easy, but I forgot one edge case where what we say I had to use another loop because at some point of time tail and fast pointer and slow pointer might point on same header, same node which is not the starting of loop. It might point over here. So what can we do is if flow is over here because most of the time what happens is, let me bring out the marker. So 1 2 next dot next next dot. So if flow is over here and we will require another result. Why this might happen is because if fast and slow pointer are pointing at same point, to reach at the start we will have to do next. We will do slow pointer next, result pointer one next, then another next of slow pointer, then another next of result pointer, which will result in us being getting 3, which is our intended output. So if you had not watched it, you can go. I will not waste much time over here. So what is this? Flattening a linked list, today's topic. Let's go directly into solve the problem because there also explanation might be there. In this question, there is no brute force approach, directly one solution. Oh my god. Here they have used priority queue and auxiliaries. Means here they have provided 2 3 methods, 1 2. But what is the problem is the time complexity is quite high, and for this question knowing multiple ways might not help. If the question is simple, knowing the multiple ways can help. But in this both are brute force approach for me. I will show you something much more easier. Mm, where is the problem statement? Okay, it's a million question, quite tricky, amongst the tricky ones in LinkedList. So reverse the LinkedList in K groups. This was one of the tricky questions I felt, and amongst them, this is also. I mean, flattening of linked list is easier than reverse a linked list. After knowing both, what we say, working, you can implement both easily. So let's read the question. Given a linked list of size n, where every node represents a sublinked list containing 2 pointers, next pointer and bottom pointer. Each of sublinked list is sorted, flattened the linked list such that the node appears in a single level which contains which while maintaining sorted order. Okay. Note the flatted linked list will be printed using bottom pointer instead of next pointer. So they want the flattening to happen at bottom pointer, not next pointer. Okay. For more clarity, you can look at the print list function in the driver code. Examples are there. Expected is I will give it more optimal solution than this. Hmm, if you want to understand example, I'm going to do a dry run. So what is happening over here? All of these elements are flattened into one single linked list with one pointer. So let's just jump into the what implementation and dry run. So today's question, what question should we take? Something big or small? Uh, Too much big, it will be very lengthy for me and repetitive. So let's take this question. 5, 7, 8, 30, 10, 20, 19, 22, 50, 28, 35. What else? 40, 45. This is the Geeks for Geeks question. After flattening, what will happen is 5, 7, 8, 10, 20, 5, 7, 8, 10, not 10, then 19. Because all of these elements are also considered. What else? 20, then 22, 28, 30, 35, 40, 45, 50. So what else do they want? Sorted single linked list. What else? The flattened linked list will flatten using bottom pointer. So this is our bottom pointer. This is our next. How we will go on is first understand how it works when it there are two linked list, means two next pointer, means one and two next pointer. Let's take some good example like 19, 22, 50, 28, 35, 40, 45. What we will do is create another node, dummy node, point result and temp over here. So h1, h2, we will check, means for both we will have two pointers. What will happen? H1 is less than h2, h1 data. Yes, so uh, this will happen. Now 22, 50, 28, 35, 40, 45. So head pointer will go down. So we will add it over here. So since this was lower, it will be updated over here. H1 will come over here. Since 50 is greater than all of this, I mean 50 is greater than 28, so 28 will come over here. This was our first iteration. I should have used the red pen to show the iteration mark. First iteration, second iteration, Now third iteration. Mm, guys, give me 1 second. Mm, sorry guys, one important call was going on. Hmm. What will happen in the third iteration? H1 is over here. 28, 35, 40, 45. We had taken H2 28, H2 incremented. All will be incremented. H2 will point at null after incrementing all. While comparing H1 with 35, 50 with 40, 50 with 45, H2 will keep on incrementing. Now H2 has become null. So we will add all the elements of H1 as it is, remaining all. Because we know since it is sorted, it will be in an increasing order. So 19, 22, 28, what else? 35, 40, 45, 50. So this one has happened. Next pointer will point to null. After this, all these previous ones will get added. 10, then 20. 5 and all its nodes. So what is the thought process? We will add the last two elements and do merging, then return that part to the previous call. After merging these two, we will return it over here and we will merge means the answer of this and this, we will merge and create something else. So what we will think is we are iterating all the elements till end, then merging it. So we have reached over here. When we have reached over here, we will return it as it is. Then after returning, a merge function will be called. We will merge this both function and again we will return. So the best process used would be recursion. So we will use recursion in order to iterate, merge, except the merging with the current one. You will understand it while implementing, or during this recursive call I am going to make. How we will start? We are at here, the first element. Then uh, what we will call, let's give it indexing. So first function we will call second function, will call third function, Link list, let's give it L. So linked list 1 will call linked list 2 dot next, dot next 3. Now we are at linked list 4. So what will happen is we will return linked list 4 as it is. Here linked list 5 will be created by merging linked list 3 and linked list 4. Linked list 5 will be sent over here. Linked list 6 will be created by merging linked list 2 and linked list 5. Linked list 7 will be created by merging linked list 6 and linked list 1. And our final linked list will be created linked list 8 after merging linked list 1 and linked list 7. So this is our recursive call. Now what will happen? I've done the dry run as well, recursive call. So let's understand the time complexity. Time complexity. Uh, all the elements of the linked list will be traversed. So we will compare, we are traversing the whole linked list, then compare and traversing the whole linked list again. So approximately O of n, where n is summation of all nodes. Space complexity. So this is a call stack, recursive call stack. But all of this are pointing to one, what we say, linked list only. So we don't require any extra space except the call stack. So uh, this amount will equal to with the number of recursive call. So it's around negligible because we don't know the length of the next number of next pointers. So it will be around one, and we are not using any extra space in all recursive call functions. If you weren't able to see this, we will recursively call until we reach end. After reaching end, we will use merge. Will return it because there is no uh, next element. So if it becomes null, so next linked list dot next equals to null, we will just return it as it is. If it is not null, so what we will do is we will get the linked list, previous linked list, which is L3, and the new linked list L4. We will merge it, send it up into the recursive call stack. So the new linked list formed L5 will merge with linked list older, which was L2, create a new linked list L6, will be sent up into the call stack, will merge with L1, creating a new linked list L8, which is our answer. Okay, so implementation is quite simple. We are just recursively calling, and we are after recursively calling, we will just merge. So when you will see the implementation, you will be surprised. Are you able to see? Yes, you might be able to see. I will check it if you are not in the next, what we say, live stream, and make it better. So let's dive into the implementation. Let's add a timer. Let's think what can happen. So the base case is if root equals to null. Most probably this will not happen, or root dot next equals to null. Return root. So this is our base case. If it is last, what we say, last linked list in the next thing, return is it as it is base function, no, base case. If it is not the base case, what we'll do, we will call flatten. No, yes, flatten node, node. Why I'm calling root dot next. Flatten dot next. We are calling, which will result in the recursive call at depth. So flatten dot next equals to flatten. What else? Let me bring the what we say notes again. So recursive call you will get it better while implementing. For me also it will get better. Flatten will call flatten dot next, and where we will store this after merging. Flatten dot next is the merge linked list. So we will be storing it as flatten dot next. That is what I have done over here. See flatten dot next. Yes. Now what we will do is after flat after returning this we will have to call merge function and then return that new to the what upper calls. So what we will do is node root equals to merge what we can say uh, root comma this row we have to use some another name. So we are just creating another root. Merge function will give us another root. We are using dummy thing, no? Let me show you in the notes. Here we are using a dummy thing, no? So it will return a whole new linked list after merging. So with a new header as well. That is why this is what we have done. After that, we will just return the new merged linked list as it is. So now something better we will do. I mean not better. The recursive call we will do, which is flatten. No, merge function. What we will get is a node b. We are getting two linked list. Should I call it L1? No. Let it be as it is. So what we will the merge function store node temporary is equals to new node containing value 0 node result equals to temporary, while a dot a not equal to null, and b not equal to null. If a dot data greater than b dot data, what we will do? Temp dot bottom equals to a bottom to a why a is less than b. Temp dot bottom, sorry, temp will be incremented to the new bottom, and a will also be incremented. A equals to a dot at bottom. Yes. Else temp dot bottom equals to b. Temp is equals to temp dot bottom. B equals to b dot bottom. Then I mean this is recursive, means common. So let's remove it out of the recursive call. Hmm, what else? After this loop, we will check are there any nodes remaining. Why we are using while loop? If a not equals to null, temp dot bottom equals to a. If b not equals to null, temp dot bottom equals to b. I mean we can do this at else also. What else? Now the whole thing is merged and sorted, after which we will just return our new head, which is res dot next. So simple. This is our base case. So if we reached at the last root, we will return it. Should we use or? If we do and, both should be true to go in. No, we want any one of this is true. This is our base. So recursively, viewer over here will recursively call over here, recursively go down. After this, next is null, so we will just return it over here. Merge this both. After merging, send it to next. So merging, after merging, 10 dot next is equals to merge linked list. Then we will merge this both, send it, means update the next has been updated, merge the merge part, and the first node will get merged, and resulting in our answer. Has everything gone right? Flat dot next, there is nothing named as flat, man. Root dot next, expected output and your output, a whole lot of difference. Hmm, what is the problem? Where did we make a mistake? Root equals to null root dot next. This is our base case. Root dot next is equals to flat dot next. Acha, flatten is also the same. Root is equals to merge root comma root dot next. Yes, return root node A while A not equals to null, B not equals to null. If A dot data less than B dot data, is it data? Yes, it is. Temp dot bottom equals to A equals to A dot bottom. Temp is equals to temp dot bottom. Temp dot bottom equals to B. B is equals. Oh, we are updating bottom. So the next is always going to be null. It's going to be right. I mean, I should have directly submitted it, but I don't like 50% accuracy, so this is the better case. 6 more to go, man. Yes, and we are rocking and rolling. It took us 11 minutes to solve, quite a high time. So, flattening a linked list. We marked at revise. Rotate a linked list. What does rotate a linked list mean? Okay, we will see it in the next live stream. Till then, bye.